process turns out the same at all times. That is, if a process takes place under a particular situation and the outcome turns out the same each time the process takes place under a certain condition, we say that that process is a law. For instance, if you throw stone up in that location where you are right now, it comes down. You go to another location, throw stone up again, it comes down. You try it in as many places across the world as possible, and the stone keeps coming down each time you throw it up. That is consistency. Consistency of outcome. The outcome is that each time you throw a stone up, it comes down. And that led to the birth of law of gravity. So anything that keeps occurring as a result of a process under the same condition at different times, that has become a law. When we carry out number operations, basic number operations in mathematics, such as addition, subtraction, multiplication, and division, we can perceive that more than one way can be adopted for carrying out such operations. We try out what we have known before as a default process, a pre-selected process, a process many persons have known to be the one that comes out of the number operation via interpretation. If you see a particular number operation in mathematics, you can quickly tell what you are expected to do. That which you are expected to do, which you discern through interpreting such number operation, is called the default method of solving that problem or carrying out that number operation. Many times people have tried testing other ways of getting the same answer to that number operation without using the default method, and they have succeeded in creating different ways of being just the same. When different methods of solving a particular number operation take us to the same answer and that becomes consistent, then we can accept both as methods of carrying out that number operation. When such alternative methods become consistent, that is, when such methods which we use alternatively to produce the same result always occur, and the persistence is seen to be a way that leads us to a conclusion that this is a law, then we accept them as laws. The consistency in the outcome of alternative methods adopted in solving a particular mathematical problem makes us call such outcomes laws, and even the process laws. That takes us to the world of arithmetic laws. This is number 5 in my series known as Foundations of Mathematics. Again, the topic is arithmetic laws. In it, I seek to show, by means of example, how we can use alternative methods to approach solving pertinent mathematical operations, or to carry out pertinent mathematical operations. Before we arrive at a conclusion, we carry out numerical experiment so that when we arrive at a conclusion, you will not be confused as to how such conclusion came to be. We can identify 3 arithmetic laws, which especially will be important when carrying out algebraic operations. Do not forget that algebra is an extension of arithmetic. Arithmetic of variables is called algebra. Invention of such alternative methods of carrying out number operations became necessary with invention of algebra. Again, we have been able to identify three basic laws, arithmetic laws. 1. Law of commutation. 2. Law of distribution. 3. Law of association. In each, we explain the bottom line and then carry out numerical experiments, convince ourselves that we have taken the right conclusion, and then use such results to simplify number operations when necessary. Let us take the first shot, and that is law of commutation. Let me use a practical situation to explain the concept of arithmetic laws. Look at these two number operations. 3 bracket 9. What does that mean? By now, you should have known that it means 3 times 9. And what is the answer? Let me say it. Obviously, the answer is 27. That is, 3 times 9 is equal to 27. What about this? 3 bracket 7 plus 2. What is the answer? Before you tell the answer, what is the meaning of this number operation? In plain terms, what is the instruction? Compare it with the first one. The first one says multiply 3 by 9 or multiply 9 by 3. That is why the answer became 27. So here, what is the instruction? That is, what is this asking us to do? Anyway, before I answer it, let me remind you that brackets are regarded as numbers. Any set of numbers put together in a bracket are seen as one number. So no matter how many numbers that are found in this bracket, as long as bracket encloses all of them, we look at them as a wrap of numbers. And that wrap is a bracket. So we refer to that bracket as one number. Therefore, this is still asking us to multiply 3 by whatever value we find in the bracket. Notice that if you add 7 to 2, the answer is still 9. The implication is that the two operations are the same. 3 bracket 9 is the same thing as 3 bracket 7 plus 2. Can you discover other ways of writing this 3 bracket 9? Obviously, you can, because it is not only 7 plus 2 that will give us 9. Somebody could come here and write 3 bracket 4 plus 5. And in many other ways, we can write this expression. But one thing stands out. A bracket is one number. Therefore, this means 3 times the bracket. That is 3 times whatever is in the bracket. Again, if you add 7 to 2, the answer is 9. So this also means 3 times 9. Like before, the answer is 27. And here it comes, the same 27. 3 bracket 7 plus 2 is equal to 27. We should take particular interest in this second number operation. Why? Because the first one is straightforward, just 3 times a single number. But in this, it is 3 times a sum of numbers. In this case, this 9 is expressed as a sum of numbers. Let us take particular interest in this. How? Is there any other way that we can get 27 out of this number operation without insisting on getting the sum of 7 and 2 and multiplying the sum by 3? That is 7 plus 2. First is 9. Then that 9 times 3 is still 27. That is true. But I'm asking, is there any other way we can get 27 as the answer without using that method of first getting the sum of the numbers in the bracket and multiplying the sum by 3? Let's find out. Any other method that we apply that gives us 27 as the answer to this number operation is also valid. That way, we get alternative method of carrying out that multiplication. First, let us try to multiply the contents of the bracket one after the other by 3. That is, let me use 3 to multiply 7, use the same 3 to multiply 2, and then carry out the resulting number operation. And let us find out if at the end the result is 27. Please watch out. And here it comes. It says, alternatively, 3 brackets 7 plus 2, which is this same number operation. This time around is equal to 3 bracket 7. That is this 3 times this 7. See it here. Then plus. That is this plus here. 3 times 2. That is this 3 times 2. So we have used 3, which is a common coefficient, to multiply the contents of the bracket. That is 3 multiplying 7, and later 3 multiplying 2. See the results here. So 3 times 7 is 21, and 3 times 2 is 6. 21 plus 6 is equal to 27. The same answer we got when we multiplied 3 by 9 straight away. Could this be a coincidence? Is it by chance that this method resulted in 27 and the first method also resulted in 27? If we have a different number operation in the same pattern as this, and we apply the method I applied at this point, please will it give us an answer that confirms that this alternative method is valid? Anyway, let me choose another kind of number operation that will help us find out whether these two same results came by chance. Please watch out. And here comes a similar operation. 5 bracket 9 minus 3 is telling us to multiply 5 by whatever the value of the bracket is. The bracket is 9 minus 3. We know that 9 minus 3 is 6. Therefore, this 5 bracket 9 minus 3 is the same thing as saying 5 bracket 6. 5 bracket 6 means 5 times 6, and the result is 30. This result is 30, and like before, we want to find out if this method that worked here before will also work for this example. Let's find out. 5 bracket 9 minus 3 is the same thing as saying 5 bracket 9, see it here, minus 5 bracket 3, see it here. Don't forget that this pattern is what we took in the first instance. The pattern of multiplying the contents of the bracket one after the other. Don't forget that the sign here shows that 7 and 2 are being added. That is, 7 plus 2 is a sum. 9 minus 3 truly is a difference. But difference is just a special type of sum. A sum is just a number we get after addition. But difference is a number we get after adding a negative number. Here we are adding minus 3 to 9. So the name is difference. But difference simply means that we are adding something that is minus. So this is a sum, and this is also a sum. But this is a special type of sum called difference. Why am I saying this? I'm saying so because if what is here is sign of multiplication, what is going on here will not be obtainable. It is happening only in the case of sum or difference. Let's make the progress here. So we have 5 bracket 9 seed minus 5 bracket 3. See it here. 5 times 9 is 45. 5 times 3 is 15. Therefore, this number operation is equal to 45 minus 15. And the answer is equal to 30. So, with this method, the answer is 30. With this method, the answer is still 30. The two methods are different, yet the answer is the same. What it means is that this is an alternative method of simplifying this number operation, just like the first. Please use what follows to help me confirm whether this is a coincidence. Don't forget that in the first instance, this method turned out to be 27. This method, which is alternative method, became the same 27. In second instance, this first method became 30. Alternative method, the same 30. Is this a coincidence? With two examples so far, I am starting to think that this is not a coincidence. On your part, use what follows to confirm whether this is a coincidence or not. Use the default method and alternative method to simplify, and then tell me if this alternative method works. Please see what follows. And here it comes. It says, please check 4 bracket 3 plus 5. Do it for me. First, use this method or this method. Later, use this alternative method, that is this method or this method, to find out if what is going on here is a coincidence. Anyway, at the end of the process, I want you to answer, does this alternative method work? Did it work with your own? Please, do it again. Did it work? Surely, it must work. I have on my own personal endeavor confirmed that this always works. This is not a coincidence. Now, we are happy to learn that for this practice of multiplying a content of the bracket, which is sum of numbers in the bracket, by another number, we have different methods that work for us. At least two methods have been seen to work for us here. We are happy to learn that. But what happens if at least one of these contents of the bracket turns to a variable? Will both of them still work? Will both the default method and alternative method work? Let's find out. Please follow me as I replace this 7 with x, and then afterwards we'll try to find out if both methods still work. Please watch out. And now we ask, what about 3 bracket x plus 2? Here I have replaced 7 with x. That does not mean that any place you see x, that it represents 7. It is just for you to trace the origin of what becomes of this letter, that I am making you know that I just replaced this 7 with x. Now we have 3 bracket x plus 2. But note that anything else could have been here apart from 7. Even if it is 12 that have been here, would have had 3 bracket 12 plus 2. That will be 3 times 14. The answer will not be 27, but the answer we get will still be correct if we apply that alternative method. So this 7 here doesn't have license to be here. It is just my choice that the 7 came to be here. So with that in mind, knowing that any number could be here. It could be 7, it could be anything. But just at this point, note that this place of this 7 is taken by x. So we have 3 bracket x plus 2. Don't forget that we had two methods of solving this kind of problem. The first method was to get the result of the sum in the bracket and multiply the sum by this number outside. Second method involved multiplying the contents of the bracket one by one by this number outside. Will both of them still work, or will only one now be working? Let's try and carry out this number operation using both approaches. And let us notice when one of them proves difficult, even impossible. Please follow along. And first, we try the default method. Let us try to get the result of this tray bracket x plus 2 by default method. The default method is that we get the result of the sum of numbers in the bracket and multiply this sum or that sum by this tray. First, we ask, what is the sum of x plus 2? That is, if I say x plus 2, what is the answer? Is it 2x? If you are thinking it is 2x, you must have missed something in fundamentals of algebra. What did you miss? What you missed is the concept of like terms and unlike terms. Anyway, if you have problem being sure that x plus 2 will not or will give us a simple answer, please get back to fundamentals of algebra and study like terms and unlike terms. Therein, we learn that x plus 2, for instance, will not simplify out. They will not reduce to anything simple. X plus 2 is a sum of two numbers which are unlike terms. One of the laws states that when we want to add like terms, the addition is irreconcilable or irreducible, meaning that we cannot add unlike terms. X and 2 are unlike terms, so we cannot get anything out of the sum. If it had been 2 times x, surely the answer will be 2x. But here we have x plus 2. We can't add x to 2. Please, can you add a goat to a cow and then get a simple result? No. You add a goat to a goat, you add a cow to a cow. And so, because we don't know what this x is, we can't add it to these two. Because of that, we cannot get anything simple out of this bracket. Consequently, this default method is how? Irreducible. That means by default, we can't make this simpler. All right, what about alternative method? Let's try out. That method involves multiplying the contents of the bracket one after the other. The contents in this case include the x and the 2. Let us try to multiply the x and 2 separately and find out if this method still works despite the fact that one of the contents has become a variable. Let's go. 3 times x is 3x. I hope we remember why. And again, 3 times plus 2 is here. That means that multiplying x by 3 is possible and multiplying 2 by 3 is also possible, as you can see in these results. So 3 times x is 3x, and then 3 times 2 is 6. It therefore means that this number operation, 3 bracket x plus 2, has produced 3x plus 6 as the answer. But by default, the same number operation could not produce any simple answer. Now, back to the question. If a variable replaces one of these numbers, will both default method and alternative method work? What will you say after seeing the results of these two? Obviously, when one of the numbers in the bracket turns to a variable, the default method fails. But this alternative method keeps working. In the case of 3 plus 7 plus 2, where everything we are carrying out operation with is known, is called the pure arithmetic. So 3 brackets 7 plus 2 is pure arithmetic. But this, in which at least one of the numbers taking part in the operation is a variable, we call it algebraic arithmetic. So this is example of pure arithmetic, but this is an example of algebraic arithmetic. So far, what lesson have we learned? When carrying out pure arithmetic, that is multiplying a sum of constants by a number and multiplying a sum of variable and constants by a number. What lesson have we learned? While you are thinking, let me write the lesson I have learned and you reconcile it with what you are thinking. Please watch out. And here comes the lesson, and it is in form of observation. It says some procedures of evaluation that work in pure arithmetic do not work in algebraic arithmetic, hence requiring alternative procedures. I hope that captures what you were thinking. Yes, you just saw it that some procedures work in default methods or approaches, but will not work when it comes to algebraic arithmetic operations. Anyway, you must not lose sight of the difference between pure arithmetic and algebraic arithmetic. That may work in pure arithmetic may not always work in algebraic arithmetic. What it means is that if we want to carry out procedures or number operations in algebraic arithmetic, we need to procure and use alternative procedures or methods. This is what we have learned so far from what transpired. With all we have observed, we can now define arithmetic laws. What then do you think is the definition of arithmetic law? Please join me as offer that definition, and afterwards check whether it makes sense to you in the light of the things you observed so far. Please see the definition of arithmetic laws. And here comes that definition. It says, arithmetic laws are alternative procedures of evaluation in algebraic arithmetic observed to work where the default procedure of pure arithmetic fails. Did you understand that definition? Do you make sense out of it? Anyway, if you look at it again and take interest in some special words used in this definition, you will discover that this is the conclusion or the summary of the lessons we have learned so far using the default method and alternative method to carry out number operations in pure arithmetic and what we call algebraic arithmetic. In this lesson, we are going to take time to learn 3 main types of arithmetic laws. That is, we have 3 main arithmetic laws we're going to learn in this pack of lessons. These laws are 1. Law of commutation. 2. Law of distribution. 3. Law of association. Please find them on the screen. And here they come. Law of commutation or commutative law. Law of distribution or distributive law. Law of association or associative law. Let us now take on the first, and that is the law of commutation. In this section number 1, that is law of commutation, we want to learn the meaning of that expression by means of numerical experiments. The results of the experiments will help us see exactly what this law is all about. Please take note of these four number operations. The first is 3 plus 5 plus 7. Please, what is the answer? 3 plus 5 is 8. 8 plus 7, what is it? Let me tell you. In fact, you know what the answer is, but let me write the answer so that we agree on one thing. Please find out. Yes, 3 plus 5 plus 7 is equal to 15. This is a sum of three numbers. Sum of 3, 5, and 7 is 15. Look at the next line of action. That is the next number operation. 3 plus 7 plus 5. Is this a set of different numbers or a set of the same numbers? 3 is still here. 7 is here. 5 is here. It means that it is the same numbers, 3, 5, 7, that have been arranged differently to be 3, 7, and 5. Okay, now that we have a different arrangement of this first set of numbers, is the answer now different? Let's find out. 3 plus 7 is 10. 10 plus 5 is still 15. All right, let's find out. This third number operation, is it operation with a different set of numbers or the same set of numbers as the first? Let's find out. 5 is still here. This 3 is here. This 7 is here. So again, we observe that this third number operation is the same set of numbers as the first, but the arrangement is different. In the first number operation, 3 came first, but here 5 came first. In the first, 5 came next. Here, 3 came next. And also, 7 came last, and it is still last here. At least one thing happened. The number arrangement is still different. All right, having seen that this operation, this set of numbers is the same as this one and this one, will the answer to this operation change from being 15? Let's again find out. 5 plus 3 is 8. 8 plus 7 is still 15. Wonderful. All right, the same 3 plus 5 plus 7 is now compared with the last operation, 7 plus 3 plus 5. If you watch carefully, you observe that this last number operation features the same set of numbers, 3, 5, 7, but in different arrangement. Here, 7 comes first, 3 comes next, and 5 comes last, unlike what happened in the previous cases. In fact, it is the same 3 numbers that have been arranged in 4 different ways. We can even arrange them in more different ways, if possible. But let's find out if this last number operation will still give us the same 15. 7 plus 3 is 10. 10 plus 5, the same 15. Let me write 15 as the answer to all these subsequent number operations. And here they come, 15 everywhere. The same 3 numbers, 3, 5, 7, arranged in 4 different ways, and the answer is the same. Don't forget that fact. What if we are multiplying? That is, let 3 and 5 and 7 multiply. This is addition of numbers that we carried out at this point. After adding 3 numbers, 3, 5, 7, in different arrangements, the same answer came up. Let us try to multiply the same 3 numbers and check if what we observed here will also be observed in that kind of number operation. Let's find out. And here they come, the same set of numbers, 3, 5, and 7. Here we have 3 times 5 times 7
The result is 105. First of all, say 3 times 5 is 15. 15 times 7 is 105. Next, 3 times 7 is 21. 21 times 5 is 105. Next, 5 times 3 is 15 times 7, 105. 7 times 3, 21. 21 times 5 is 105. The same set of numbers, but in different orders. 3, 5, 7, 3, 5, 7, 3, 7, 5, 3, 7, 5, 5, 3, 7, 5, 3, 7, 7, 3, 5, 7, 3, 5. So the same set of numbers, but repeated or presented in 4 arrangements. In the first case, we considered addition of numbers. In second case, we considered multiplication of numbers. But at the end, we discover that no matter what happens, no matter the arrangement, the answer is the same. The sum of the same set of numbers arranged in 4 ways all produced 15. The product of the same set of numbers arranged in 4 ways all produced 105. Let us now try to write the summary of this observation. The summary of what transpired here and what transpired here. Please watch for the summary. And here comes the summary. Before then, notice that the answer we got here and the answer we got here and here are all the same. It means that this number operation is the same thing as this number operation, the same thing as this number operation, the same thing as this number operation. So they are all equal to one another. This is the summary, one of the statements of the summary. So 3 plus 5 plus 7 will give us the same answer as 3 plus 7 plus 5. The same answer as 5 plus 3 plus 7. The same answer as 7 plus 3 plus 5. And the answer becomes 15. Don't forget. Also, when multiplying here, the same set of numbers arranged in 4 ways in multiplication give us the same answer, 105. It means that this product and this and this and this product have the same value. This takes us to the conclusion that 3 times 5 times 7 will give us the same answer as 3 times 7 times 5, the same answer as 5 times 3 times 7, the same answer as 7 times 3 times 5, which is ultimately equal to 105. It is time for us to take a look at the law of addition and multiplication of the same set of numbers. Before then, what did you observe? First, you should have observed that in adding numbers, it does not matter which number comes first and next, because no matter which number comes first and next, the answer is the same. Here, numbers are being added. The same set of numbers being added. The result did not change because of arrangement of numbers. That is, the numbers kept commuting, that is, changing their directions and positions, and yet the result remained the same. The same is applicable to multiplication. When numbers multiply, the arrangement of those numbers in the multiplication does not affect the result. So in both addition of numbers and number multiplication, the way the numbers are arranged is not important, because no matter the arrangement, the result is always the same. Notice that this observation is applicable to, so far, number addition and number multiplication. Yet we have 4 different basic number operations. Does this work in subtraction? And does this work in division? Let's find out. And here they come. That is subtraction and division. In subtraction, let's try with 7 minus 2 and then 2 minus 7. When we are subtracting, the number that comes first is important. Let's find out. 7 minus 2. In this case, 7 comes first and 2 comes next. Let this sign be a sign of subtraction. But if this sign is not a sign of subtraction, then it might be seen to obey commutative law. But as long as this sign remains sign of subtraction, the implication is that this sign does not belong to 2. If this sign minus is a sign of owing, definitely it is belonging to 2. And wherever 2 goes, it carries it. And 7 will carry its plus wherever it goes. But because this minus is not used as a sign of owing, but used as a sign of subtraction, then it must remain constant while these 2 numbers change their positions or exchange positions. Let 7 be here and let 2 be here, as it appears here. 7 minus 2, get the answer. The answer is 5. Then if you have 2 minus 7, get the answer also. The answer is minus 5. Plus 5 here as a result, minus 5 here as a result. The implication is that 7 minus 2 does not give us the same result as 2 minus 7. This is a sign of is not equal to. Therefore, 7 minus 2 is not equal to 2 minus 7. Therefore, the way numbers are arranged is important in subtraction. What about division? We have, for instance, 4 over 2, which means when 2 divides 4. If you say 4 over 2, the number below is that divides the number above. So 2 divides this 4, the result is 2. Then we now have, let 2 and 4 interchange their positions so that this 2 goes up and 4 comes down. The result we get, will it change? The answer is yes. So if the result is 2 here, what will it be here? 2 over 4 is equal to 1 over 2. So the result here is 2 and the result here is 1 over 2. And we cannot state correctly that 2 is equal to 1 over 2. Therefore, again, in division, 4 over 2, for instance, is not equal to 2 over 4. In division, therefore, the way the numbers are arranged is important. The number on top, the number below, when exchanged, will change the result. Likewise, in subtraction, the number that comes first and that which comes next, when exchanged, will change results. It is only in addition and multiplication that the results remain the same thing, no matter which number comes first or next. Now, that takes us to the statement of the law of commutation in words, and afterwards, we summarize the law in symbols. Please, watch out for the law of commutation in words. And here comes the statement of the law of commutation or commutative law in words. It says, in addition and multiplication of numbers, the result is the same irrespective of number arrangement. I hope that the words used in this statement capture the sentiment that you had while we performed or while we took part in carrying out numerical experiments that led to this conclusion. In addition and multiplication, the numbers commute. That is, they change positions, and yet the answer is the same. Let us now see how to state the law in symbols. In statement of the law in symbols, we capture what happened here and what happened here. Let A and B and C stand for the three numbers that are added and multiplied. It is not restricted to three numbers. We can have 5 numbers, 4 numbers, 6 numbers, and more numbers being added or multiplying themselves. In this case, we have only 3 for simplicity. Again, let us state the law of commutation in symbols. And here comes the statement of law of commutation in symbols. Let A and B and C represent these numbers, so that to have A plus B plus C, the answer you get in it is the same thing as you get if you change the arrangement to A plus C plus B, and the answer you get when you change arrangements to B plus A plus C and arrangements to C plus A plus B. This is in the sum of numbers, that is number addition. Let us see number multiplication. ABC is equal to ACB equal to BSC equal to CAB. Again, don't forget the bottom line. In law of commutation, the number arrangement does not matter because the result is always the same. Let us see more examples of number operations that highlight the importance and veracity of law of commutation. And here come the more examples under the law of commutation. The first is this: 2 plus 3 plus 9 is the same thing as 2 plus 9 plus 3, the same thing as 9 plus 2 plus 3, and the answer in each case is equal to 14. Second, 5 plus 6 plus 1 is the same thing as 6 plus 5 plus 1, the same thing as 1 plus 6 plus 5, which eventually will give one result, 12. Number 3, 4 times 3 times 5 is the same thing as 3 times 4 times 5, the same thing as 5 times 4 times 3, which will in the end get the same answer as 60. The fourth is 7 times 3 times 2 times 5 is the same thing as saying 7 times 2 times 3 times 5, the same result as 5 times 2 times 7 times 3. The result in each case is equal to 210. The time has come for you to check whether you've been following what I've been saying. Please watch out for a simple exercise. And here comes the checkpoint. It says, rearrange the numbers in the following operations in as many different ways as possible according to commutative law. Hence, give the result. 1, 9 plus 4. 2, 8 plus 5 plus 2. Number 3, 10 plus 1 plus 7 plus 3. Number 4, 6 times 5. Number 5, 7 times 3 times 2. And number 6, 3 times 2 times 5 times 6.